Graphing rational functions. Rational polynomials, rational functions. Unlike regular equations, when we deal with rational functions, let's do an easy one real quick. We have to look for asymptotes and zeros. Because once you find the asymptotes and the zeros we mean by intercepts. Once we find those, then we'll have a better picture what the graph looks like. So, in this example, what do we have? With the asymptotes, do we have any horizontal, oblique, vertical? How do you find the vertical asymptotes? Denominator equal to 0. So we have x plus 2 equals 0. So right now we have a vertical asymptote at -2. You either have horizontal or obliques. You cannot have both of them. How do you determine horizontal asymptotes? Degree of both numerator and denominator. Just of their leading terms. If the top is bigger than the bottom, what do we know? Case in point. So if we had x to the 5th over x third, we can cancel out 3 of them, so we have x squared. What is the graph as x goes to infinity? What is this approach? What's infinity squared? A bigger infinity. So this one goes to infinity. So there is no horizontal asymptote if the top is bigger than the bottom. If the top and the bottom are equal in degrees, in other words, if we had 2x to the third over 3x to the third, the x to the thirds cancel. So we're only left with the coefficients. So the horizontal asymptote is the leading coefficients. If the top is less than the bottom, We can cancel out 3 of those, so we have x squared on the bottom. As x goes to infinity, this number goes to 0. So our horizontal asymptote is 0. Remember, the horizontal asymptote is the y value. It's a horizontal line. So when the horizontal asymptote being 0 is the line y equals 0, which is the x-axis. The horizontal asymptote being a over b, it's the horizontal line a over b. Now, oblique asymptotes occur only when the top is bigger than the bottom by 1. So if we had x to the 4th over x to the 3rd. Because when you do division, then you'll get a linear equation. If you have oblique asymptotes, you have a diagonal line or a line with a slant. All right, so let's look at our example here. We're saying that our vertical asymptote is -2. Do we have a horizontal asymptote?
No.
No. What do we have? Oblique? Why?
Because the exponent is bigger.
Yeah, the top is bigger than the bottom by 1. So to find the oblique, we use long division. So in our case, we got x plus 2, x squared plus 5x plus 6. Look at the leading terms. What times x gives me x squared? X. So x times x is x squared. X times 2 is positive 2x. Now we have to change the signs. We have to subtract. So we have to change the signs and add. The first term always has to cancel. 5 minus 2 is 3x, and bring everything else down. So what times x is 3x? A positive 3. Positive 3 times x is 3x. Positive 3, positive 2 is positive 6. Change your signs and add. So let's look at something here real quick. Oh, no, I don't want that. I don't want that. So what do you think our equation is going to look like when we graph it? Plus 5x plus 6. Oh, that's our graph. Look familiar? Where do you see it? Look at your paper. Long division we just did. That's x plus 3, yeah. It crosses at 3, and the slope is up 1 over 1, up 1 over 1. Because when we did the long division, there was no remainder, which means, what does that tell us? Since the remainder is 0, it tells us that our function can be simplified into that. The top can be factored out, and the bottom cancels. So we have what's called a removable discontinuity. Our asymptote doesn't exist anymore because we canceled it out. That's how we can tell we got a 0 remainder. That means it's a perfect factor. So what that means is our graph of our function looks like this, with a hole at whatever value when x equals -2.
So it looks like a straight line, like a line like for x plus 3, but the asymptote is still there as it goes, still in graph is right.
If we zoomed in, there's an open hole right there. There's an open hole right there. Because we can't use -2 from our original equation. But the rest of the graph exists.
If the graph is actually the asymptote, it's not really it's not really a horizontal asymptote.
Well, no, it doesn't. Okay, it has an oblique asymptote. In this case, it has an oblique asymptote.
So, but I thought the graph was the oblique asymptote.
It is. It is, but because the remainder is 0, that means the denominator can cancel with something in the numerator, which means it's no longer a rational equation. So that I threw that in there just because it can happen. That's why whenever you have polynomials, always factor them out first. How do y'all feel about factoring? We may have to spend it. Actually, I think we do that later on. Yeah, we do it. I apologize because, again, the way they have this chapter situated, we learn how to factor polynomials in section 6 after we talk about these other rational ones of polynomials. So it doesn't make too much sense to me. But anyway, so let's look at some other examples. So what do we notice about this one? So whenever you have polynomials, first thing you would do is see if you can factor them. Why is that important? Okay, in this case, we have a polynomial on the bottom. What can you not have on the bottom of a fraction? You cannot have a zero. So we have to solve this equation for zero. The way we do that, see if we can factor it first. If that doesn't work, you can always resort to the scientific quadratic formula. So x squared is x times x. The second term is plus. That means that both of these signs have to be the same. They have to be whatever the first sign is. So they're both pluses. Now we have to figure out two numbers that multiply to equal 4. When we add them, it equals 3. Is there anything? No. So we can't use the factor method. So we have to use the quadratic formula. But you have to find out where your function is undefined. What is A, what is B, and what is C? What is A? Remember, a quadratic equation looks like this. A is whatever, yeah, in front of x squared is 1. B is, and C is, so just plug those in there. Don't use a calculator. I don't use say calculators in this room. I'll teach you how to think. Especially if you want to be an engineer, you better have very quick number sense. Very few engineers ever really jump on calculators. Very few of them. If they want to keep their job. So what happens to the radical? What's radical -7? It's an imaginary number. So it's I radical 7/2. What does that tell us about our solution set? This is from algebra.
There's no.
So there's no real solutions. There's no x value that'll make it equal 0. Which means we have no vertical asymptotes. Do we have a horizontal asymptote?
No.
Well, it's 0 because
Oh, yeah.
there's more x's on the bottom. So it's the x-axis. Do we have any zeros? What's the only way a fraction can be equal to 0? If the top is equal to 0. So we have a 0 across the x-axis at 0. But there's also our horizontal asymptote. Can you have a point on the horizontal asymptote?
asymptote.
Horizontal asymptotes you can have a graph that looks like this. If this is your horizontal asymptote, you can have a graph that looks like this, but it'll taper down. It can cross the horizontal asymptote, but then it eventually has to taper down towards that. The only one you cannot cross is the vertical asymptote. The horizontal asymptote you can cross it once, but then it has to taper off after that.
Should only.
No, it actually should ideally not cross at all. It should just like 1/x squared. It should approach it
Right.
and never touch it.
Sorry, I said if it does cross it, though, we never go back in, right?
No, yeah, it won't cross again. Because once it finishes, it'll dampen out. So what's this graph going to look like? We have an x, the solution is 0 there. Use your calculator or cell phones. Take it away, push it away from you. It's not that necessary. What's the graph going to look like now? If you don't know, then plot some points. Make an XY chart, plot some points. Plot a couple of negative points, plot a couple of positive points, see what happens. So when x is -2, what's y going to equal? -2 over -2 squared, 3 times -2 plus 4. -2, 4 minus 6 plus 4. Negative, that's 8 minus 6 is 2, so it's -1. What happens at -1? It's 5 minus 3 is 2, so it's -1/2. At 0, it's 0. What about at 1? 1 plus 3 plus 4 is 1/8. At 2, 4 plus 6 plus 4, it's 1/7. So you see what's happening? It crossed through we don't know what's going to happen here yet. We have to plot some more points. What happens here? It crossed it. Now it's going to taper back down. So now we're more interested in now what's happening on this side, since there is no vertical asymptote. What happens at -3 and -4? See if we see a pattern. So it's 9 minus 9, -3/4. And -4. We have -4 over 16 minus 12 plus 4. So it looks like it's doing this. Let's see. Squared plus 3x plus 4. That's exactly what's happening. So when you plot graphs, always look for vertical asymptotes, horizontal asymptotes, and zeros, intercepts. All right, let's look at another example. Let's do a simple one. Graph that one for me. What do we notice about this? What's the basic function of this? Since there's only one x, what's the basic function here? What does that graph look like? So do we have a vertical asymptote? Where? Yeah, take the bottom, set it equal to 0. So we have a vertical asymptote at -3. So at -3, we have a vertical asymptote. Do we have a horizontal asymptote? The horizontal asymptote is 0, right? Because there are more x's on the bottom. As x goes to infinity, this function goes to 0. So we have a horizontal asymptote at the x-axis. So the function 1 over x is just shifted over 3 spaces to the right, to the left. Let's look at this one. So look at the asymptotes. Do we have a horizontal asymptote? Because the degrees are the same, it's the coefficients, so it's 1. Do we have a vertical asymptote? At 3. Set the bottom equal to 0. So our horizontal asymptote's at 1. Vertical asymptote is at 3. We have to figure out now what the graph looks like. How do we do that? Yeah, plot some points. Do we have any intercepts? Do we have any x-intercepts? Do Do we have any x-intercepts? Very good. Because the x-intercept is simply set y equal to 0. Set this equal to 0. Only way is 0 is at the top of 0. So take x plus 2. And that gives us our x-intercept. We have our x-intercept at -2. Do we have a y-intercept? Very good. Set x equal to 0. We got 2 over -3, which is -2/3. The x-intercept, you set y equal to 0. The y-intercept set x equals 0. So we have -2/3, which is approximately there. Not going further, I can pretty much just tell you what the graph's going to look like. Since we know these points are here, it's got to cross those. There can't be another graph up here. So it's either going to be here or here. We know it's not here because it's not an even function. So since it's an odd function, the graph will look like this. Plot some points. Okay, let's look at another one. Let's look at this one. Do we have a horizontal asymptote? And since there's more on the bottom, it's 0. Do we have a vertical asymptote? Well, first off, we have to take this equation and see if we can factor it out. Plus, so they're the same. They're both pluses. What times what is 3? When we add them, we get 4. 3 and 1, right? So my vertical asymptotes are at -3 and -1. It's just the opposite, what's inside there. Do we have an x-intercept? -2 because set the top equal to 0. We have a y-intercept. It's just the constant, right? Because you set all the x's equal to 0, what you're left with is the y-intercept. Okay, so this is our horizontal asymptote. Vertical asymptotes are at -3, -1. We have an x-intercept at -2 and a y-intercept at 2/3. Whenever something like this happens, these outer ones, they're always usually in the opposite quadrants of each other. Very rarely will they always be on the same side. Unless they're both squared. So we plot some points. And we put in 1. We put in 1, we get 3/3/8. Is 3/8 higher or lower than 2/3? Lower. Because 4/8 would be a half, which is lower. So if we look at negative a half, so I have negative a half plus 2, negative a half squared, 4 times negative a half plus 3. So this is 4/2, which is positive 3/2, which is 1 1/2. 1/4 minus 2 plus 3. 1/4 plus 1 makes it 5/4. So we have 3/2 divided by 5/4. What does that become? 3, take the top, flip the bottom. 6/5, which is 1 1/5. So we see a pattern. That's ideal. Let's look at this quadrant. Because it's going to be similar to this one. Either it's going to be up here or it's going to be down here. So this is 1 1/5. So let's try -4. All I need to see is if it's positive, it'll be like that. If it's negative, it'll be down there. So we have -4 plus 2, positive 16 minus 16 plus 3, negative 2/3. So we know it's going to look like this. Now the middle section. That's going to be the tough one. Because it's just a small confined area. So we look at, this is -2. So we have -2.5 and -1.5. What's going to happen here is inside these small sections here in the middle. Typically, if it's the horizontal is 0, they'll look like either like that or like that. Since we know it crosses at -2, it's not going to be a parabola. We just have to figure out which side is it going to go down or is it going to go up. So let's try at -2.5. Which is -5/2. So we have -5/2 plus 2. -5/2 squared. 4/2, so it's -1/2 on top. 25/4 minus 10 plus 3. Minus 10 plus 3 is -7. Which is 28/4. That should be -3/4. The negatives cancel, so we have 1/2 times 4/3, which is 2/3. For our graph, it's positive. So the graph will look like this. The hardest part is plotting the points. Finding the asymptotes, finding the intercepts, that's the easy part. Once you get that, we know how it's going to look. The outer ends are typically going to be either diagonal or they're going to be on the same side. You just have to check one point to see where it's above or below the horizontal asymptote. Anytime you have anything in the middle, it's typically, if you have an x-intercept, it's typically going to be a decreasing or increasing function. Anybody get that? Or are you still looking at it like it's got 3 heads?
What
Hmm?
is-
Maybe 4 heads, yeah. So the steps are always the same. Whenever you have polynomials, factor them out first. Find horizontal and vertical asymptotes or any removable discontinuities. Then find the x and y intercepts and plot some points. You can't go wrong from there. One more. Okay, the first thing we're going to have to do is factor out the top and bottom. This one is a difference of 2 squares. X squared minus 2 squared. And this one, x, that's negative, so they're opposite signs. The bigger number gets a negative. What times what is 4? When you subtract them, you get 3. Yeah, 4 times 1, 4 minus 1. And the bigger number gets a negative. Right. So what's my horizontal asymptote? Because they're both the same, it's the coefficients. What's my vertical asymptote? Yeah, set the bottom equal. Yeah, so -1 and 4. What's my x-intercept? Yeah, so set the top equal to 0, so you get -2 and 2. What's my y-intercept? Set all the x's equal to 0, get -4 over -4, makes it a +1. All right, that should give us a good idea what the graph's going to look like. So I have a horizontal asymptote at 1. That's one. So vertical asymptotes at -1. And 4. X-intercepts at -2 and 2. And y-intercept at 1. All right, so make our chart. Since we know we have one here, and that's an asymptote, what do you think this side looked like? Like that. So let's look at this. 1, 2, 3. Let's look at 5. What happens at 5? We get 25 minus 4. 25 minus 15 minus 4. 21. 10 minus 4 is 6. 3 and 3, 3.5. So this half looks like this. What happens in the middle? We have an intercept there. Can you guess what it looks like? Yeah. Like that. Very good. Very good. Pretty easy. Okay, I'm not gonna lie to you. It's not that easy because you have to factor everything out first and then plot the points. If you can't see it, then plot some points. This part here. Yeah, that's why after you try your attempt, you get the numbers and everything, it should start coming to you. You see where the x-intercepts, the y-intercepts are. It can cross the horizontal asymptote. There's no law that says it doesn't have to. It can cross it once, but then it tapers off. So, yeah, it's just plot the points. And these outer limits, they're always going to be some of that shape. It's not going to be a parabola. If it did, then you have multiple zeros, or it'd be a quadratic equation in itself. All right, that's it for that section. Y'all want to do the next one? Okay, let's do the next one.